Previously, we saw how we can determine reorder point in a continuous review system in order to satisfy some target service measures. We consider cycle service level and fill rate. Here we'll consider the same issue but in the context of a periodic review system. Here we want to determine the restocking level in which will satisfy some given service measures. This is how the inventory level and inventory position looks like in a periodic review system. Here we assume that lead time is constant but demand is uncertain. This figure, as I mentioned, shows the on-hand inventory or inventory level and inventory position as functions of time. So we have some inventory on hand, time goes by, inventory level decreases, some demand materializes. Time goes by and we reach time t0. At time t0 we will check the inventory and see if it is below level R restocking level or not. If it is below level R, so we will make an order to increase the inventory level to level R. Of course here it is less than R, so we will make an order of this size. But we will not receive this order immediately. It will take L units of time, lead time, right? And then after L units of time we will receive the order, so our inventory level will increase by the same size of the order that we made previously. Dashed curve shows the inventory position, which, if you remember, was the summation of the inventory on hand and the inventory on order. When we make an order to increase the inventory to level R, then inventory position, in fact, increases to level R. And when we receive that order, then the inventory position and inventory level equate to each other. Time goes by and we reach time t0 plus rp. In fact, rp is the reorder period, so it is the second time in this let's say in this case that we are considering that we will go and check the inventory. Here again the inventory level is less than R, we will make an order to increase it to level R. Inventory position increases to level R, but we will receive the inventory after L units of time, so it is only after L units of time that the inventory level will increase, and the increase will be equal to the size of the order that we have already made. And time goes by and the same story will repeat again. Note that the inventory that we have at time t0, either on hand or on order, which is equal to R, will be consumed over a period of time equal to Rp plus L. It is from time t0 to time t0 plus Rp plus L. And therefore, the deficiencies that we have here, or the number of stockouts or back orders that we have at time t0 plus Rp plus L, depends on the restocking level and also the aggregate demand over the period from time t0 to time t0 plus Rp plus L, or a period of length Rp plus L. So what we want to do is to determine the restocking level in order to protect our system from stockouts over a period of length Rp plus L. If you remember from the continuous review system, the protection interval there was L. So we wanted to protect our system against the stockout shortages over a period of time equal to L lead time, and then we did it by choosing an appropriate reordering point. But here we'll choose a restocking level to protect the system against shortages, and to satisfy some given service measures. Let's start with cycle service level. We have the cycle service level given and denoted by S1, and we want the probability of demand during the period Rp plus L being less than or equal to R, or the probability of having a shortage over the period of time Rp plus L be the probability of not having a shortage over this period of time be at least equal to S1, and we will do so by choosing a restocking level. We assume demand during the period Rp plus L is normally distributed with mean mu Rp plus L and standard deviation sigma Rp plus L. The discussions and argumentations are just the same as we did for the continuous review system, except for the interval that we are considering. There we consider the lead time, but here we are considering Rp plus lead time. So we can say that the probability here on the left hand side can be rewritten as this probability in which n is a random variable that follows a standard normal distribution, and we want to set a R that will give us this probability equal to S1. To do so, we need to define Z as the z-score corresponding to the service level S1, and then when we get SLZ based on S1, then we have this equation to solve. So we have the Z, we have mu, we have sigma, and to find the R, we need to solve this equation for R. So we'll get this expression here. So restocking level is equal to the average demand over the period Rp plus L plus safety factor Z multiplied by the standard deviation of demand during Rp plus L.